Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video compares and contrasts using the old school approach and StatCrunch to solve uniform distribution problems. Let's get started. To demonstrate these different ways of solving uniform distribution problems, let's look at an example problem involving customer wait times. So the time a customer must wait in a checkout line for a given retail store is uniformly distributed between 0 and 7 minutes. We're asked to find the probability that a customer must wait no more than 5 minutes to check out. So to solve this the old school way, the first thing we're going to do is draw a rectangle. So here I draw my rectangle. This is the shape of my uniform distribution. Second, I'm going to label the range of my distribution. The range for my distribution is found here in the problem statement. It says that we're uniformly distributed between 0 and 7 minutes. So those are going to be the bounds for my uniform distribution, between 0 and 7. Next, we're going to calculate the height. They didn't give us the height in the actual problem statement, so we have to use that dandy formula that we talked about in the last mini lecture to solve for that. So we're going to take the difference between the max and the min, and then we're going to take the reciprocal of that. So 7 minus 0 is 7, and then we just take the reciprocal of that and get 1/7. So there's the height of our rectangle. Now we're going to identify the area inside our distribution and calculate that area to get our probability. So what we're looking for is the wait time that's more than 5 minutes. So that's going to determine the little shape of the rectangle inside the bigger rectangle that we're going to have to calculate the area for. So we shade in the portion of our rectangle that's greater than 5 because we want the probability of more than 5 minutes wait. Then we actually are going to be looking for the area of that rectangle. Well, it's just length times width, or in this case, width times height. So the height is going to be the 1/7 that we calculated earlier. The width of the rectangle is going to be the 7 minus the 5. So when we punch those numbers out, we get 2 times 1/7, or 2/7, which comes out, when we divide that out, 2 divided by 7, that gives us 0.286. So there's a 28.6% chance that we're actually going to have a wait time greater than 5 minutes. Okay, that was the old school way. Let's see how to solve the same problem using StatCrunch. Here we go. Okay, we're here in StatCrunch, and I'm going to show you how to calculate that uniform distribution probability for the customer wait time. So first we need to get our uniform distribution calculator. To do that, I'm going to go up here to Stat, Calculators, and then go down here to where it says Uniform. Pulls up my uniform calculator. So now the problem statement said that our wait times are uniformly distributed between 0 and 7. So that's the lower and upper limits. So between 0 and 7. And then we want the probability that our customer wait times are greater than 5. So here we have to change this inequality from less than to greater than. And look, there's our probability right here, the 28.6%, or the 2/7. That's all there is to it. Okay, so you can see StatCrunch is pretty easy once you know what to do with it. I actually prefer to use StatCrunch to do it, but let's look at another problem to demonstrate how to solve uniform distribution problems both ways. So here we've got a gasoline station, and at this particular station, they're selling gasoline according to a uniform distribution between 2,000 and 5,000 gallons per day. So we're asked to find the probability that the station is going to sell between 3,500 and 4,000 gallons today. So the old school way of doing this, first we're going to draw our rectangle. So there's our rectangle. Then we're going to label the range for our distribution. So we've got to find our max and min values, and that's going to be here in the problem statement. We're uniformly distributed between 2,000 and 5,000 gallons. So we're going to mark that here on our rectangle. And then we're going to calculate the height of the rectangle. It wasn't given in the problem statement, so we've got to use that handy dandy formula to get that. Just take the difference between the max and the min, and then the reciprocal of that difference. That gives us the height for our rectangle. Now we're going to find the area inside that rectangle that corresponds with the probability that we're looking for. So we want between 3,500 and 4,000 gallons. So that's going to be an area that's going to correspond to this little guy right here. So between 3,500 and 4,000, we want the area for that little blue rectangle that's shaded there. So that's the area we're looking for. That's going to be the same as our probability. And we can find the dimensions of that rectangle pretty easily. The 1 over 3,000 we calculated earlier. The width for the rectangle is just going to be that high value of 4,000 minus the low value of the 3,500. That difference is going to give us the width for our rectangle. So then we just multiply those two quantities together, and we do the math, and out comes 1/6, or 16.7%. Again, let's show you how to do this in StatCrunch.
Okay, we're back in StatCrunch, and I'm going to show you how to tackle that gasoline sale problem, asking for the probability with a uniform distribution. So first we need to get our uniform distribution calculator. I go to Stat, Calculators, Uniform. And here in my uniform calculator, I need to put in the lower and upper limits. The problem said that we're distributed between 2,000 and 5,000 gallons a day. So I need to put those numbers in here. Between 2,000 and 5,000 gallons a day. And then it said we want the probability between 3,500 and 4,000. Well, I could enter in both those numbers here and then get this probability value and then do a little subtraction. But it's easier if I just come up here and hit between. And now I can put in two different values here for my probability. So we want between 3,500 and 4,000. I hit compute, and voila, there is the 1/6, or the 16.7% that we just saw. So it really is that easy. Hope that helps you.
And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.